Just 2 weeks after the most powerful Starship launch in history, SpaceX has already started testing Flight 13. Not planning, not preparing, testing right now. Meanwhile, just a few miles away, Blue Origin watched a $1 billion rocket catch fire on the pad. The blaze burned for hours. The entire launch system shall reduce to ash. 2 companies, 1 week, 2 completely different fates. What exactly is SpaceX doing with Flight 13 that makes this pace seem impossible? And Blue Origin, do they have any path back? All of it, right now. 2 weeks after the most powerful launch in human history, SpaceX didn't take a single day off. While the press was still writing analysis pieces on Flight 12, the engineering team at Starbase had already started prepping Flight 13. The very next day. This is not normal aerospace industry tempo. This is something else entirely. For context, Boeing took more than 2 years between Starliner flights, and Starliner is a small capsule, not a 120-meter, 5,000-ton rocket. SpaceX did it in 14 days. So how? The answer isn't genius. It isn't luck. The answer is a production system built from day one to run in parallel, not in sequence. Most rocket companies operate in a straight line. Launch, analyze, fix, then start building the next vehicle. Every step waits for the one before it. SpaceX runs it in reverse. While Flight 12 was in the air, Booster 20 and Ship 40 were already in the Megabay, being inspected, being assembled, waiting for live data from the flight to apply immediately. When Flight 12 landed, Flight 13 was already at the next step, not the first step. No other space company on Earth is operating at this scale. And it explains why the gap between SpaceX and everyone else is widening, not closing. But that speed isn't always clean. What happened on Friday night at Starbase is the clearest proof of that. The night nobody slept. The story no one is telling. Dark outside, around 2 a.m. Booster 20, the super heavy stage for Flight 13, taller than a 20-story building, began its roll from the Megabay to the Massey's test site. And immediately, boom, things started going wrong. The transport vehicle, the only specialized rig on Earth capable of moving a Starship booster, started getting stuck. Inside the bay, out on the road, stuck. Move, stuck again. Not fully broken, just not right. The engineering crew worked in the dark. No soft deadline, no option to quit, because Booster 20 was sitting in the middle of the road. You can't just leave that until morning. After hours of troubleshooting, they isolated the issue. A power unit failure on the right side transporter. Not a soft reset, a full replacement. Right there, in the dark, on the road to the test stand. They called in more hands, brought out the equipment, pulled the old unit, installed the new one. By the time the Texas sun started breaking over the horizon, Booster 20 was moving again. One long night. No sleep, nothing went to plan. But nobody stopped. Nobody said, we'll deal with it tomorrow. They fixed it, right there, right then, and kept going. This is what cameras don't capture. No clean renders, no official announcement, just a crew working in the dark to keep the program on track. And once Booster 20 finally reached Massey's, the real work began. Cryo test. The test a rocket cannot fake its way through. Think of it this way. You take an enormous metal vessel. You pump it full of fluid, nearly 150 degrees Celsius colder than air at the South Pole. The entire metal structure contracts, expands, and takes massive internal pressure all at once. If there's any crack in the thousands of welds, if any valve can't hold pressure, if any joint is even slightly weak, it will show up. Right now. No hiding, no delaying. Physics has no exceptions. That's why cryo tests exist. And SpaceX is about to run one on Booster 20 in the coming days. Meanwhile, the ship sitting above it, Ship 40, is waiting for something far more significant. Ship 40 and the point of no return. Ship 40 is still sitting on its stand in the Megabay, quiet, stationary. But in the coming days, it will receive something that decides its entire future. Raptor 3 engines. Here's what matters. Not the spec sheet, but the meaning of engine installation. The moment Raptor 3 is bolted onto Ship 40, the clock starts. You can't pull it back off for another test run. There's no undo. The next step is static fire. Real engines, real propellant on a real test stand. This is where all the design work, all the simulations, all the theoretical calculations get checked by reality. The engines either work or they don't. This week, Raptor 3 units have been spotted moving through the Starbase facility. That's the clearest signal. Installation is imminent. But before Ship 40 can fly, the pad has to be ready. And what's happening at Pad 2 this week is far more complex than what's been reported. Pad 2, what they're pulling off and why no one is explaining it. From the outside, Pad 2 looks almost normal after Flight 12. That's exactly what's unusual. The most powerful rocket in human history launched from here 2 weeks ago. 74 million newtons of thrust hammered the ground for several seconds, nearly double the thrust of the Saturn V, the rocket that sent humans to the moon. And the pad is still standing. Not by luck. Because the water deluge system beneath the pad did exactly what it was designed to do: absorb and dissipate that massive thermal energy before it could destroy the structure. But SpaceX doesn't stop at good enough. They're pulling everything apart and inspecting it piece by piece. And here's the detail most people are missing. This week, SpaceX removed all booster clamps and their protective covers from the pad. Why? 2 theories, both important. Theory 1, routine deep inspection. Pull everything off. Check every weld, every joint, every load-bearing point. Make sure no micro cracks formed after the launch. Theory 2, SpaceX is preparing a booster clamp design change, based on data collected from Flight 12. If that's true, this is a much bigger signal. It means they learned something from that last launch that hasn't been disclosed yet. We don't know which one is right, but this is exactly the kind of question you should keep in your head as updates from Starbase continue to come in. And while the ground is being inspected, the launch tower is being upgraded in a way most people haven't noticed. Mechazilla, the mechanical arms that catch a rocket falling from the sky, is getting a significant upgrade this week, but not in the direction you'd expect. SpaceX isn't making it bigger, not adding raw force. They're making it lighter. The full rail system on both catch arms has been removed and replaced. The new version eliminates the circular cutouts along the rail length, keeping only what's structurally necessary. Why does lighter matter? Think of it this way. When you need to catch a ball moving at high speed, a lighter arm reacts faster. It adjusts more precisely. It absorbs impact energy more efficiently. This isn't an aesthetic change. It's the direct result of data collected across Flight 5, Flight 6, and Flight 7, 3 successful booster catches. Each catch generated data on impact force, required reaction time, and which sections of the rail absorbed the most load. The new version was designed from real data, not theory. SpaceX then ran 30 consecutive extension and retraction cycles to validate consistent behavior after installation. 30 times. Back to back. Not to test once, but to confirm repeatability. Because when you're catching a 70-meter booster falling out of the sky, close enough is not an option. Now, here's what many people miss. Lighter rails mean the damper system, the shock absorbers, needs a full recalibration. SpaceX removed several dampers this week. That tells you the calibration process is underway and not yet finished. When is it done? That's one of the 4 hard requirements Flight 13 must clear before it flies. I'll walk through all 4 at the end. But first, SpaceX is doing something no private company in history has ever attempted: building 4 launch pads simultaneously across 2 states. 4 pads. Why this number changes everything. At Space Launch Complex 37 in Florida, the LR-13000 crane, one of the largest ever deployed in aerospace, has been erected and is ready to begin assembling the launch tower. The lower tower sections are being clad with exterior panels on site. SpaceX is doing it in parallel, not sequentially. And those pile drivers at the front? That's the foundation for a second pad in Florida. Add the 2 pads in Texas. SpaceX is building 4 Starship launch pads at the same time. No private company in history has ever done this. But here's the part most analysts get wrong. Why do 4 pads matter more than any single flight? Because SpaceX's goal isn't to launch Starship. The goal is to launch Starship many times per month, often enough that cost per launch drops to a level no rocket in history has ever reached. And you can't do that with one pad. One pad goes down, the entire manifest stops. 4 pads. If one needs maintenance, 3 keep flying. This is the long game, not about the next flight, about the next 200 flights. At the same time, Starbase is building out a complete fuel self-sufficiency ecosystem, an on-site liquid methane production plant, a natural gas liquefaction facility, expanded liquid nitrogen and liquid oxygen storage. The end goal, Starbase produces all its own propellant, no dependency on any external supplier, a fully self-sustaining launch facility. While SpaceX builds that future, Amazon is staring at its launch manifest and confronting a very uncomfortable truth. The Kuiper math. These numbers don't lie. 330 satellites. That's all Amazon Kuiper has on orbit after everything launched so far. Their stated goal, 3,236 satellites to compete with Starlink. Run the math. They're 2,906 short. Each launch carries approximately 45 to 50 satellites. Amazon needs at least 60 more launches just to hit the minimum target. At current launch cadence, there's no guarantee they get there before 2030, and the situation gets worse every week. Look at what Amazon has left to work with. Atlas V, out of production. Only 7 remain. 6 of those are already allocated to Boeing Starliner, a program with its own problems. That leaves exactly 1 for Kuiper. Ariane 6 Block 2, upgraded version with a more powerful P160 motor, can carry 36 satellites instead of 32. But this will be its first flight in the new configuration. And in aerospace, first flight of a new config always carries risk. Vulcan Centaur, still under investigation. Solid rocket booster anomaly, timeline unknown. And if the investigation links the BE-4 engine to the New Glenn explosion, Vulcan faces another investigation round on top of the current one. New Glenn just exploded on the pad, grounded for months minimum. That leaves one very specific, very uncomfortable question. Who flies those 60 remaining missions for Amazon? The realistic answer right now is a single name: SpaceX Falcon 9. And here's the sharpest irony in the entire Kuiper story. The only company with the capacity to launch Amazon's internet constellation is Amazon's direct competitor in the satellite internet market. Will Amazon have to go to SpaceX to keep Kuiper alive? That question is the hottest debate in commercial space right now. Drop your take in the comments. The fire at LC-36 burned for hours. When the Blue Origin engineering team finally got access to the site, they were bracing for the worst. And then they realized the worst didn't happen. The entire propellant storage system, liquid oxygen, hydrogen, liquid natural gas, intact. The massive launch support tower, repairable in place. The HIF building housing the booster and upper stages, nearly untouched. Only one thing was completely destroyed: the transporter erector. And here's the twist no one expected. Blue Origin had already been planning to retire it. They'd been moving toward a vertical integration structure system before the explosion. The fire didn't derail their plan. It just forced them to execute it faster. This wasn't pure disaster. This was a company being forced to modernize faster than planned, in the most painful way possible. Can they fly before end of year, as Dave Limp announced? Given the workload remaining, it's a stretch. But with Jeff Bezos behind it, nobody's going to call it impossible. Stoke Space and Vast, 2 names you haven't heard enough. While the big stories dominate the headlines, there are quieter things happening that are changing the industry in more fundamental ways. Stoke Space continues Zenith engine testing at Moses Lake. This week, there's one detail worth noting: a thin layer of frost forming on the exterior of the first stage during testing. That means they're pumping real liquid oxygen and nitrogen into a real rocket structure. Not a simulation, not an isolated component test. This is the signature of full system integration testing getting close. Stoke Space doesn't get much coverage, but they're attempting something even SpaceX hasn't fully solved: a fully reusable rocket, including the second stage. With Starship, the ship hasn't been routinely recovered yet. Stoke wants to do that from day one. If they pull it off, cost per launch could drop another full order of magnitude, below what even Falcon 9 can compete with. Vast, the private space station company, just signed an agreement with the French government for 2 crewed missions in 2027. Mission 1. Legendary astronaut Thomas Pesquet returns to orbit on a private flight to the ISS. Mission 2, and this is the one that makes history, ESA astronaut Arnaud Prost will fly on the first crewed test flight of Haven 1, the first commercial space station in human history. If everything goes to plan, Arnaud Prost will be among the first humans to live and work on a facility owned by no government on Earth. And NASA just made a decision that connects directly to all of this. They had been considering maintaining a government-managed core module split off from the ISS as the nucleus of a future station. But after hearing from the private sector, NASA dropped the idea. The reason? Private companies already have the capability. If NASA steps in to manage the infrastructure, they'd be disrupting the very market they're trying to create. This is the biggest shift in US space strategy since ISS was built. NASA becomes the customer, not the owner, of future space stations. Stoke Space, Vast, NASA, all pointing in the same direction. The era of private spaceflight isn't coming, it's already here. But before that era can move further, Flight 13 has to fly. And here are the 4 hard requirements standing in the way. 4 conditions. When does Flight 13 actually fly? This is the question everyone is asking. And here is the most honest answer the current data can give. Flight 13 has no official launch date. Not yet. Anyone giving you a specific date right now is guessing. But there are 4 hard requirements that must be met before SpaceX is authorized and ready to put Flight 13 on the pad. Condition 1. Booster 20. Cryo test must succeed. Booster 20 just arrived at Massey's. Cryo test is coming. If any issue surfaces, the timeline slips. No exceptions. Condition 2. Ship 40. Static fire must be completed. Ship 40 needs Raptor 3 installed first. Then it rolls to the test stand. Then the engines fire, for real. Each step is a gate. Fail the gate, you don't move forward. Condition 3. Mechazilla must complete calibration. New rails are installed, but the damper system is still being tuned. Until 30 consecutive test cycles run clean, the catch arms are not considered flight ready. Condition 4. FAA sign-off after the Flight 12 mishap investigation. SpaceX is actively investigating the boostback failure on Booster 19. Findings plus corrective actions go to the FAA. FAA reviews and approves. Only then does the launch license get issued. 4 conditions. All 4 must be green simultaneously. If nothing unexpected surfaces, and late 2025 is a grounded, optimistic scenario. If something does, no one can tell you when. And here's what a decade of covering this industry will teach you. Something unexpected always surfaces. The question isn't whether there will be surprises. The question is how fast SpaceX responds when there are. Based on what we've seen over the past 2 weeks, that answer is already pretty clear. 2 weeks, 4 launch pads, 1 explosion, Flight 13 already in motion. This race has no finish line. If this analysis added value, like, share, and subscribe to the Space Brief. And drop a comment below. Can Blue Origin fly before end of year?